Okay, so here's my audience. And my sister's in the hospital, so she is joining us remotely. And there you go. Hi, so I'm here today to talk to you about molecular gastronomy. Every time you eat, have you ever considered how the food ended up on your plate? Why aren't we eating raw steaks anymore? How do raw eggs turn into scrambled eggs? What if chefs could harness the science behind cooking and use it to transform in ways that we've never thought of? This is the science of molecular gastronomy, learning how and why food reacts the way it does, and using that to transform the ordinary into extraordinary. Being a professionally trained chef for 15 years, I've understood the principles of cooking, but in order to become a great chef, you have to understand the principles of chemistry. Here, I will not only introduce you to the magical world of science behind cooking, but introduce you to the ways that chefs are trying to manipulate it and change the way that we eat. Molecular gastronomy has been around as long as we have been cooking, but it never became a formal field until the 1980s when physical chemist Heavy Thies tried to understand the science behind cooking. He was hosting a dinner party one night and was making a souffle, which the recipe called to add 2 eggs in at a time. However, he said, I'm just going to add all the eggs in at once, and it should work. The souffle fell, and it didn't work. That spurned the question, why did this happen? What is the difference between adding all the eggs versus 2 eggs at once? From that, he started partnering with one of his colleagues and opened a molecular gastronomy lab, and the field of molecular gastronomy was born. Believing that if they had a better understanding of why certain foods are cooked the way they are and what happens to the foods when they are cooked, they could unlock new worlds of innovation in the culinary world. Over the next 25 years, the practice of molecular gastronomy would sweep mainstream, with renowned chefs such as Heston Blumenthal and Ferrandin Ari bringing the concepts to the public in restaurants around the world. What exactly is molecular gastronomy, though, and why study the chemistry behind cooking? Let's say that you have some rice. Have you ever considered what happens inside the grain of rice to transform it from a hard piece of rice into something that's soft and palatable, such as a risotto or a pilaf? On a microscopic level, rice is composed of carbohydrate molecules of starch that are laid down in its central core. These granules, the starch granules, are composed of 2 different kinds of starch: tightly packed amylose and loosely packed amylopectin. Amylose is very tight in its chemical form, and amylopectin is very loose with more space in between the molecules. Both of them react differently in the presence of heat and water, with the loosely connected amylopectin breaking down faster and easier and releasing its starch out into the water. With every variety of grain of rice, it has a different ratio of amylose to amylopectin. This is why you can cook a risotto and a pilaf, and they are completely different depending on which grain of rice you use. Arborio has a high level of amylopectin, while jasmine has a high level of amylose. The amylopectin lends that creamy texture to the risotto. This is molecular gastronomy. Knowing why products behave the way they do, you are then able to manipulate them to cook more efficiently. But how does the understanding of science of food affect you as a diner? Molecular gastronomy is shaping how you eat without you even knowing it. For instance, when we think of ice cream, we often think of something cold and hard and creamy that comes in a tub. However, Dipping Dots partnered with molecular chemists and realized that you could use liquid nitrogen to flash freeze the water molecules in ice cream and create small spherical ice cream spheres. This is how Dipping Dots was born. On a bigger level, aside from what you eat or how you eat it, it can have an effect on the entire global scale. Researchers have recently found out that one of the main ingredients in meat proteins is a protein called myoprotein. Myoprotein is a protein that lends meat not only its meaty flavor, but its liquid texture. Using that knowledge, they were able to create it in a food lab and then infuse it into wheat gluten. What this means is that you can take wheat gluten, infuse it with myoprotein, and have a protein that is completely like meat but is not animal-based. However, what does this mean to you? Livestock cultivation and agriculture contributes to over 18% of the CO2 emissions and greenhouse gases, leading to global warming. It is one of the largest causes of why we are experiencing global warming today, surpassing transportation, surprisingly. Being able to understand the chemistry behind food allows us to manipulate it in order to make it in a more efficient manner and cut down on those CO2 gases. Chefs are able to take the chemical principles of cooking and apply them in new ways to invent new and better foods. If we're able to use the knowledge gained on food preparation, we might find ways to even make healthy foods more attractive, because really, who likes to eat Brussels sprouts or broccoli all the time? One day, we might be able to harness the power of those minerals and energy and transform it into something that you actually like to eat. We might persuade people to cook better food, and last but not least, we might convince society to regard eating as a pleasure rather than a necessity. This could lead to an increase in healthy eating, a greater appreciation for food, decreases in obesity, and greater utilize our food resources, which are constantly dwindling. In conclusion, the field of molecular gastronomy may be a new one, but it has been influenced food since fire has met meat. It focuses on learning and harnessing the powers of chemistry and physics in order to perfect the art of cooking. And whether you realize it or not, molecular gastronomy is happening on your plate every time that you eat. Thank you.